Hi, unfortunately there is some renovation at Lazarski, so I couldn't use their facilities. So this last topic, I'm gonna just discuss with you using the notes I've been making for you. Okay, and look, today we're gonna discuss customer choice theory. This is a subject you will be discussing in details during your intermediate microeconomics class next semester. So I'm gonna just explain briefly the economic parts, and later I'm gonna show you in detail how to handle the most basic customer's choice theory model that uses the uses optimization under constraint that we've been practicing in mathematics class and in previous videos. Okay, so look, in customer's choice theory, we introduce a concept called utility. Utility basically is the satisfaction that a customer received from consumption of a given good or a service. Now, it is something really hard to quantify, but I hope I'm gonna be able to explain to you the intuition behind it. You can think of it as a happiness that customer gets from consuming a given amount of goods. And actually, this brings us to total utility. Total utility is exactly satisfaction, total satisfaction from consuming a given amount of goods, given number of goods. So, for example, out of consumption of 7 sandwiches or 2 cans of cola, something like that. Okay, and look, we're gonna start easily. Let's just say that we are considering only one good. This is our utility function. Utility function is some function of x, where x denotes the quantity of good. Capital letter X for simplicity. Look, we do not need to know the exact shape of this function. We just need to know some of its properties. And as usual, we're going to do it using derivatives. And we assume that the first derivative of utility function with respect to x, so quantity of good x consumed, u prime, we will be calling marginal utility. Look, marginal utility is just like marginal cost you learned about in microeconomics. This is additional satisfaction that you receive from consumption of one additional good. So look, basically total utility tells you total satisfaction if you consume 7 sandwiches. But marginal utility gives you the amount of satisfaction you get from eating the last sandwich. So now going from number 2 to number 3, by how much your satisfaction increases. From sandwich number 3 to number 4, by how much your satisfaction increases. And look, generally, the empirical results and pure reasoning actually shows us that total utility function should be behaving in a very specific way. And this way is described to you in the first graph over here. Look, basically we see here increasing concave shape. And this is described by marginal utility being always positive, but the second derivative of total utility being always negative. What does it mean? Well, look, it means that when you consume, let's just say that you're very hungry and you see in front of yourself a plate of sandwiches. Now, when you're eating, each additional sandwich you eat will bring you some additional pleasure, additional satisfaction, additional happiness, right? So your total utility will be increasing, right? But it's different. You will be getting different satisfaction from consuming each consecutive sandwich. Because look, when you're very hungry, the first sandwich will give you a lot of pleasure. But then you are a little bit less hungry, so the next one will also bring you some satisfaction, but a little bit less. And look, with each consecutive sandwich, you have eaten more, which means that you're no longer starving. You're eating, let's just say, just for pleasure of eating. So each consecutive next sandwich will bring you less and less additional satisfaction. And this is basically the entire idea behind the utility that we use in economics. Okay, so now let's move to a situation when we need to choose between more than one good. And we will actually concern ourselves only with the choice between two goods. In microeconomics, we use very specific tools to describe the situation. Okay, first one. So let's introduce a couple of the definitions we use there. First, a bundle. Bundle is a set of goods a customers choose to consume, right? So basically, you see it over here. The bundle we will be denoting like as xy where x is the quantity of good x consumed and y is the quantity of good y consumed. So basically this ordered pair xy is a set that tells you how many units of good x, capital X, the customer consumed, and how many units of good Y the customers consumed. Okay, next thing is like when we purchase goods, of course we do not have unlimited resources. So the next tool we're going to introduce is a budget constraint. Budget constraint is simply a set of all the combinations of quantities of good X and Y that customer can afford. Look, if you have a given amount of money, you can spend it all on good X, you can spend it all on good Y, or you can choose some combination of them in between. And look, we, for simplicity, will be assuming the customer is not saving, so the customer spends all the money at his or her disposal. Okay, so how do we introduce budget constraint? Look, let's assume that B, capital B, is customer budget, Px is price of good X, and Py is quantity of good Y. Look, now budget constraint can be expressed as B equals Px times X plus Py times Y. And I hope you remember that we actually used this constraint when we were dealing with optimization issues under constraint in our mathematics class, which gives you a hint how will we use it later on when we will actually go to the customer model. Okay, now this equation we can very easily rewrite in a way that will allow us to draw it. Look, if I move px times x to the other hand side of the equation and divide both sides by py, I'm getting y as a function of x. Okay, and look, what you see over here, this negative px over py, is the slope of this line. We see it has negative slope. If we put y over here, if we put x over here, oh, I'm sorry, here py is missing, but look, if we spend our entire budget on good y, how many units of good y can we buy? We divide b by py. If you have $100 and good y costs $10, then you can buy at most 10 units of good y. So this would be this point. Now, if good x costs $5, if you want to spend all your money on good X, how many units you can purchase? Well, you divide your budget by the price of good X. 100 divided by 5 gives us 20. So here we would have 20. And look, the straight line you see over here shows you all the combinations of quantities of good X and Y that customer can afford, assuming the customer spends his or her entire budget. Okay, and now, so this graph actually tells us a little bit more, because look, we see that everything above the green line are the combinations of these two goods the customer cannot afford. He doesn't have, or she doesn't have enough money to purchase it. Below the green line, we see the combinations that customer can afford, but having spent money on one of these combinations, there would be still some money left to purchase more. We are only, of course, interested on what is happening along this line. Okay, and the final tool that we use in customer's choice theory is called indifference curve. Indifference curve shows sets of all combinations of quantities of good X and Y for which the customer receives exactly the same total utility. Okay, imagine a case like that. That you are offered, you came to a restaurant or like a fast food. Oh, that would be easier to grasp. And let's just say that you like hamburgers and French fries equally. So it would be indifferent to you if you would get 2 boxes of French fries and 1 hamburger, or 2 hamburgers and 1 box of French fries. Look, it would also be indifferent to you if you get 3 boxes of French fries or 1 hamburger and 2 boxes of French fries. In this case, all those combinations are indifferent to you. But look, this is not how it actually works in reality, right? The case is that usually when we have a lot of something, we value less the additional unit, right? This is exactly what we see in the previous graph. Look, if you already ate like 3 hamburgers, then maybe, and you're still hungry, you probably will be valuing French fries a little bit more than the next hamburger. Another way around, if you already ate many French fries, boxes of French fries, now you would prefer to have a hamburger instead. Look, you can see this in your life. It's like when you eat, for example, the same food for a couple of days, even though it's your favorite food, at some point of time, you get sick of it and you just want something different. And basically, this is this idea at work. Now, how do we see it mathematically? Look, this is our utility function of the customer. So this is a total utility that customers get from consuming good X and Y. Now, what we see over here is that we can actually expect the changes in your utility, so in the satisfaction taken from consumption, can come from 2 sources. Changing the amount of good X you've consumed and good Y you consumed. So look, basically, it can be described by this total differential. But now look, the assumption of indifference curve is that all the combinations of 2 goods should give you exactly the same total utility. So this is why, to obtain indifference curve, what we do is we compare this differential to 0. Because look, here we will have some increases in x and some decreases in y, but your total utility is not changing. So accordingly, du must remain constant at 0, which means that utility you gain from from consuming these goods remains at a constant level. And look, if I'm gonna take this equation, I'm gonna first put ux dx on the other hand side, then divide both sides by dx and uy. I'm gonna receive the slope of indifference curve. This slope of indifference curve has extremely important interpretation in economics. Okay, look, first, what do we have inside? Ux here is derivative of u with respect to quantity of x consumed. It will definitely be positive. The more x you consume, the happier you get. And the same goes for uy. Uy is a partial derivative of u with respect to quantity of y, and it's also positive because the more of y you consume, the happier you get. But as you see over here, if I divide ux by ui, both positive numbers, I get positive number, but we have minus up front, which means that this the slope of indifference curve is negative. And actually, the slope of indifference curve in microeconomics we call marginal rate of substitution. Marginal rate of substitution is simply telling you how many units of good X the customer is willing to give up for one additional unit of good Y while maintaining the same total utility. So the same satisfaction. And look, this indifference curve has this convex shape that you see over here. And why do we have this convex shape? Let me show you with a very simple example that refers to the concept of total marginal utility for individual goods. Look, imagine that we are starting at point X over here. Now, I'm sorry, over X over here, X0 over here, and Y0 over here. Now, look, at this point, we see that the customer has a lot of good Y, but very little of good X. So look, now, if the customer would give up some of good Y, the loss in his total utility would be relatively small. Because marginal utility, when you have this many units of good Y, is rather minor. On the other hand, look, marginal utility for good X is very big. Why is that so? Because you have very little of it. So each next consecutive unit you get is actually bringing you a lot of additional satisfaction. So you see that here, at this moment, customer would be willing to give up a lot units of good Y in order to get one additional unit of good X. But look, as we move along the indifference curve, situation changes. Because look, when we move from point X1, Y1, now customer will be having very little of good Y and a lot of good X. So now additional utility from next unit of good X is small, and additional utility of good Y is big. This is why we have this convex shape of the indifference curve. Okay. Now, couple more words I'm sorry, I need to go a little bit lower. About the indifference curves. Look, I showed you two indifference curves over here. Like, and the question is, which one of these two indifference curves is better? U1 or U2? And actually the answer to this is very simple. Look, good A, bundle A is at indifference curve 1. In this bundle you have x0 of good x and y0 of good y. And look, on indifference curve U2, there is bundle B, where you have x1 of good 1 and x of good x and y1 of good y. And look, so it means that in bundle B, you have more of good x and more of good y. So definitely, this bundle B, is better than bundle A. Now, but on indifference curve, U1, we have also point like C. And look, at point C, we have more of good x2 than at point B, but we have less of good y. Now, we should notice that A and C are on the same indifference curve. So it means that they bring the customer exactly the same total utility, and the customer is indifferent between the two. But what does it imply? If customer prefers B to A, and A and C are indifferent than him, then customer definitely is going to prefer B over C. And this brings us to conclusion that each point at U2 must be better than any point at U1. So look, what customer wants is to get at the highest possible indifference curve. So the indifference curves, while getting higher and higher and higher, are getting better and better and better. And look, the same principle works with the budget constraint. If we have more money, let's just say at the beginning B was $100, now B is going to be $200, it means that you can buy twice as much stuff with the money you've got. So in the budget constraint in this case would go up and you can afford more stuff. So look, in this space, XY space, generally the customer prefers to be as far from the origin as possible. But look, on one hand, customer wants to be on the highest possible indifference curve. On the other hand, the customer cannot afford unlimited amount of X and Y. So how the customer chooses, this topic we will take up in the next video. Okay, thank you for your attention. See you in the next video. Take care.